My name is Nur Hilman bin Ahmad Sabri. My metric number is 2010322261. So for my part, I will explain or discuss about circuit in LT-Spice, steps to generate the waveform, result and discussion, DC analysis, transient analysis, and AC analysis.
Assalamualaikum and good day. My name is Muhammad Ahmad Amiruddin bin Khalid. My number metric is 2010 31480. I will be presenting 3 slides for this mini project of analog integrated circuit design.
Hi doctor, my name is Vignesaran Alaki Murugan. My metric number is 2010311499. In this mini project, I will do the presentation about the introduction, calculation and comparison, conclusion and the evidence throughout this mini project. For the introduction, our title for this mini project is Design and Analysis CMOS Analog Circuit in Systematic Method on 130 nanometer. So here we provide the reference paper we are used to this mini project, and then we use the LT-Spice platform to do the analysis such as DC analysis, transient analysis, and AC analysis.
So in this slide, I will be presenting the methodology of our mini project group. The first step is finding a suitable design, and next we will discuss the design and parameter with group member based on the design that we have chosen on the reference paper. Moving on, we will run the simulation for the design, and if we ever encounter an error, then we will change the parameter design until we complete running the simulation, and then we will be gathering the DC, AC and transient analysis using LT-Spice software. Lastly, we will compare the result with theoretical calculation and the expected outcome based on the reference paper. Thank you. So for our circuit schematic, based on the reference paper, they use an OTA operation. So what is OTA? The design that we use is the single stage operation of transconductant amplifier. Essentially, OTA is a voltage to current converter where the voltage is converted into an output current. So for our circuit specification and parameter, our design have 6 transistors. Each pair of the transistors have their own width and length ratio. So for the first pair, we have 6 micrometer with 1/1 micrometer ratio. And for the second pair of transistor, we have 22 micrometer over 1 micrometer ratio. And lastly, for the second pair, we have 1 micrometer over 0.5 micrometer. For our supply voltage, we decided to use 1.8 voltage because based on the reference paper, they does not share the supply voltage. And the last parameter is input bias range is around 0.5 micrometer and the load capacitance is 1 picofarad.
This is our schematic circuit that we have drawn in LT-Spice. In reference paper, it did not mention about the value of VDD, capacitor, current, and Vin. So we assume the value, which is the VDD, we put 1.8 volt, and Vin also we assume the value, and current is 0.5 micro, and capacitor load, which is we put 1 pico farad. We have drawn the schematic circuit, then we can start to generate the waveform. For the DC, we no need to change the parameter in the waveform. So for the transient, we put the 10 milli stop time, and for AC analysis, uh, we put a type of sweep. We choose the decade, number of point per decade. We put 10. So the start frequency we put 1, and for stop frequency we put 100 megahertz. In result and discussion, we will discuss about DC analysis, transient analysis, AC analysis. We have gain and phase, uh, both the theoretical calculation and computer simulation analysis, and a total of five graph that we able to generate from the simulation in LT-SPICE. For DC analysis, as you can see in the figure, so we have able to get the value of the DC, which we use to detect the voltage and the current each the component that we have put in the schematic. This is our transient analysis waveform that we got after we simulate or run uh, from the circuit that we have drawn. So we plot the graph into the V out, positive V in, and negative V in. For AC analysis, this is our waveform that we got. So after plot at the V out, the graph is same like reference, but the value of gain is different. After that, to check the phase margin, I plot one more graph which is V in positive. Then we put the cursor into the intercept of V in positive and V out. So we got the phase which is 90 degree.
For the calculation and result comparison part, we are able to do some calculation to find out the open loop gain and the AV. So from the reference paper, we didn't get the enough way to identify the open loop gain, so we did by ourselves. So from the table, we know that we almost get the similar value of open loop gain, 25.18, and from the analysis or the simulation, we get 25 dB. For the phase margin, both have the same value, which is 90. For the conclusion, the mini project designed as mentioned in the methodology with a single stage operational transducer amplifier OTA with the 6 transistor at 130 nanometer technology. So we carry out 3 types of analysis: DC analysis, AC analysis, and transient analysis. From DC analysis, we get to know the transistors are performing the saturation region. From AC analysis, we obtain the gain value of the operational amplifier, 25 dB, and the phase margin is 90. From the transient analysis, we able to identify and make sure the V in positive and V in negative is 0.9 volt, and we obtain the output value 1.635 volt. In the conclusion, all the objective of the mini project is achieved. This slide shows the evidence where we form a WhatsApp group and we do some chats on how to do the mini project in an effective way. This slide shows the second evidence where all the team members meet up for doing the DC analysis and transient analysis for our mini project. This slide shows the third evidence where all the team members meeting for the AC analysis, and we also discuss about the presentation slide and divide the work for all the 3 members. We really want to thank Dr. Nurhawati Hamad and Dr. Razaidi Hussein for guiding us in this mini project. The guidance that have been given from both of you are really meant and help us to finish the mini project on time. Thank you so much.